Alright, this lesson reviews the properties of rhombuses. So first we're going to go over some of the properties of rhombuses that are different from rectangles and parallelograms, and then we'll practice applying those properties. So remember, with our family tree, we start off with quadrilaterals, and then it breaks up into trapezoids and parallelograms. From there, parallelogram has rectangle and rhombus underneath it, and then they together make a square. So today we're going to focus on rhombus. So in a rhombus, what's special about a rhombus is all the side lengths are congruent. And also in a rhombus, the opposite sides are parallel, which they take from the parallelogram. Remember, a parallelogram's property is that its opposite sides are parallel and the opposite sides are congruent. What's special about the rhombus is that all four sides wind up being the same. Another special property is that in a rhombus, the diagonals, those lines that go sideways across the vertices, they bisect each other and they're perpendicular to each other. Remember that word perpendicular means they form right angles. In the rhombus, the diagonals also bisect the angles on the corner, making them into two equal parts, cutting them in half. So let's work on some practice problems here with these rhombuses. So in a rhombus ABCD, if AB is 10, what's the side length of every other side? Well, for a rhombus, all the sides are congruent, so every other side has to be 10. If angle ABD, so ABD is 50 degrees, that's this angle here, and angle ACD, what would be angle ACD's measure? Well, just like in a parallelogram, opposite angles are congruent, so that means that angle ACD is also 50 degrees. If ABD is 50, what's the measure of CDB? So what's this angle's measure? Remember, angles on the same side add up to equal 180. So if I do x plus 50 equals 180, I can solve for that angle. So x equals 130. So angle CDB is 130 degrees. So with the rhombus, all the sides are the same, and then the angles that are opposite of each other are congruent. Same side or consecutive angles are supplementary. They add up to equal 180. Let's practice with the diagonals. Draw diagonals WY, so here's WY, and XZ. In a rhombus, the diagonals are perpendicular, so they make right angles in the center. They also bisect each other. So this part's congruent to this part, and this part is congruent to this part. The point where they intersect, we're going to label as point T, and then answer these questions. If WT, so this part's WT is 5, what's TY going to be? So if you know this part of it, the other part is the same, it's 5, making the whole thing 10. WY is 10. But TY is just 5. If the entire thing, XZ, is 12, you take 12 divided by 2 to get the pieces to find XT. So XT is 6 and TZ is 6. So let's use these properties and do some practice problems. Find the missing value in each problem. So this first one, they're telling you this side is 15. So that means that every other side has to be 15. In this question, it's asking for angles. So I know the opposite angles are congruent, so I know that the measure of y is 30 degrees because opposite angles are congruent. To find x, I add them together and make them equal 180. So I have x equals 150. Flipping it over to the back. Similar types of questions. If I know this is 45, then I know angle D, the value of y, is 45 degrees as well. And then to find x, I take x plus 45 and make it equal to 180, because those angles should add up to equal 180 that are on the same side. So x equals 135. To find the missing side lengths here, I know in a rhombus all the sides are the same, so these have to be the same. Try 15 through 18 on your own and see if you can get those problems done.